The second part in the rigging process is binding a skin, which I always think is one of the grossest things you can say out loud. But nobody asked me, so I guess it doesn't matter. Now, when I bind a skin, what's going to happen is these joints that I've made are going to start controlling not the box itself, but the vertices that comprise the box. So basically, when I made this box, and you've probably been asking yourself, why does this box have so much geometry? Ha ha ha. When I made the box, I wanted to be sure that it could read as a hard surface. So here it is in 1 mode, here it is in 3 mode. To do that, you do need a little bit of extra geometry, and although I always encourage my students to keep their models as low as possible and as simple as possible, you just need a lot of geometry sometimes. So this vertex right here, which actually lives over there, is an integral part of the box's surface. But the box is just made up of these vertices. It contains a lot of vertices. So the box itself is an object, and the object is kind of irrelevant. The vertices that make up the object are the part that we care about. Now, with that said, I'm just going to take a quick look at my box. It looks nice and clean. There are no extra inputs on it. I know that my skeleton is set up to match the existing geometry of the box, so I'm feeling pretty good about that. Before I do this, I'm going to take my root joint and, just to be extra organized, I'm going to put it inside a group node, and we'll call this one my skeleton group. And the skeleton group isn't going to do much right now, but it'll come in really handy when we get into a more complex rig. So there's my skeleton group, and that contains my joints. I'm going to add that to a layer. So I've got my joints on a layer. Let's call this one my skeleton layer. And now the big trick. What I want to do is I only want to bind the joints I think I'm going to need. So when I was doing my naming, I mentioned that these end joints are always going to rotate a little bit funny. They're also kind of a silly place to have a rotation point because there's nothing above them. So like this one here is going to be a good rotation for the flap. This one here is going to be a good rotation for the side. The only thing that this top one does is it gives me some wiggle room with the funny rotation that happens at the top of each joint chain. I don't necessarily want to bend that to my skin, and if you have extra joints bound, it can cause you issues. So I want to be very specific with what I'm binding. My selection is going to include only the things that have a JT suffix. And I can go through manually in my outliner and select the JTs. To do that, I'm holding down the Control or the Command key in order to select multiples and not get these stupid little end joints. The other thing that you can do is you can use a select by name. You won't see select by name by default. It's under this little flag that is kind of hidden. And then when you open that flag up, it's going to look like this. It's going to look like absolute transform. So I'll open that up. And if you click on the icon, you can switch this to select by name. There's the list. I want select by name. If you're going to do a select by name, you're going to put in an asterisk, which is a wildcard. Then JT is the thing you actually care about. And then do another asterisk, because sometimes you wind up with like a number after the JT or some other thing. That'll give me the exact same selection. So you just selected all the JTs and ignored the other things. And once you get used to the select by name feature, it's a little bit quicker. So there are the joints I'm going to rig, and I need to select my box. So here in my perspective view, I can use my Shift key to select it. If you want to use your outliner, again, use Control or Command so that you don't mess up your existing selection. The skin bind lives in this skin menu, and you'll know that there are lots of things going on here. Because this is a really simple exercise, the only thing that we're going to use is bindSkin. We may also use unbindSkin if we don't like the way that the skin was bound. So that's always an option. You can always unbind your skin. However, we're just going to do a really quick, simple bind, and then we're going to do a lot of weight painting afterwards. So with bindSkin, this is another one that you always want to run through the option box. So I'm going to go Skin, bindSkin, option box. And then in the bindSkin options, let me just reset this so you can see what it looks like by default. There are a few things that we're always going to want to change in the bindSkin options. The first one is bind to. By default, it's set to your whole entire joint hierarchy, which would include these end joints. So instead, I'm going to switch it to selected joints. Done. The bind method is set to closest distance. And with the bind methods, closest distance is the dumbest one. It just looks at which vertices are around the joints and associates them with the closest joint. Closest in hierarchy is supposed to look at the joint hierarchy and the object hierarchy and try to match them up, which may not do much in this circumstance because we've only got one object. Heat map is supposed to be a little bit smarter than these two, so it looks at like your warmest spot, which is usually your middle, and associates that with the root joint and then tries to get colder as it goes out from the root joint. And that's great for bipeds, but I find it to be a little bit finicky. And then geodesic voxel is this really complex process that the computer does. I don't know how it works. You don't know how it works. We don't have to know how it works. I've heard that what it does is it sets up these big 3D pixels and then kind of collapses them in on the joint and associates them that way. I like it. I think it's a great way to start. I would probably go either closest distance or geodesic voxel. Honestly, neither one is going to work. You just have to kind of accept that. None of your bind methods are actually going to give you a good bind. They're just a starting point for a good bind. So it doesn't matter which one you use. Use the one that has the coolest name. Let's just go with that. The skinning method we're going to leave set to classic linear, and what this means is that when a joint controls a vertex, it controls that vertex on a system where 0 is no control, 1 is full control, and any decimal place between 0 and 1 is some degree of control. Since we're just starting out, I think that this is a good, sensible way for us to do this. This is going to be fine. We're going to leave that alone. The only other thing I'm going to change is max influence. This is the maximum number of influences that any given vertex can have. 5 is way too high. Way too high. I'm going to turn it down to 3 because 3 will still allow us to have some smooth bending, but it won't drive us crazy when we go through the weight painting process. And that's about it. When you get to a more complex rig, you may want to turn this colorized skeleton on or off because it will make your skeleton pretty colors some of the time, and then other times it won't. So you may want to turn that off. I like it because when I see some colored joints, I know that the skin has been bound, but that's up to you. It's okay. So that's about it. We're going to bind 2 selected joints. Set whatever bind method you like, and turn your max influence down to 3. Those are the big things. I'm going to go ahead, I'm going to press apply, and the computer is going to do a little bit of thinking because geodesic voxel takes a little bit of thinking. And now I've got this one joint selected, and when I rotate it, the flap kind of rotates with it, which in some ways is all I'm really looking for. So go ahead Test out your bind method. You're going to get some weird results no matter what method you used. They're all going to give you some weird results. Now, you'll note that when I'm testing mine, I'm only using rotate. I mentioned earlier that joints are rotation points. Joints are not meant to be moved or scaled. They are only meant to be rotated. And I know that when you look at them, you're like, but they have translate, but they have scale. Rotate your joints, that's all they're meant to do. So go ahead, test out your bind by rotating some of your joints. If you don't like what you're seeing, zero your joints back out, select your box, run skin, unbind skin. That will remove the effect of the joints, but now you'll have to go back and select your joints, select your box again, and then try a different bind method. Closest distance went way faster than geodesic voxel. Honestly, they're all going to have different problems, every single one of them. So what we're going to do in the next video is we're going to do some weight painting. And weight painting is how you actually make the bind look good. So I think I'm actually going to go back and I'm going to do the geodesic voxel again. I like that one better. They're all just starting points. Everything is just a starting point. So find something you think you can live with for a few minutes. And in the next video, we'll go back and do some actual editing to make the bind functional.